Hello, dear students. I am Shiv Kumar Asaladde, Assistant Professor, Department of Pharmacology, Shulingeshwar College of Pharmacy, Almala. Today we learn regarding bioassay of acetylcholine. Acetylcholine is a parasympathomimetic or cholinergic agent. Acetylcholines mainly causes skeletal muscle contraction by acting through nicotinic cholinergic receptors, and as well as it can act on the smooth muscle through muscarinic receptor, where also it is involved in to cause the contractions of the smooth muscles. So acetylcholine acts on muscarinic receptor. It opens sodium channels. Then the sodium ions can enter from extracellular fluid into the intracellular fluid and causes depolarizations due to accumulations of sodium. So depolarization is responsible for opening of calcium channel, then as well as release of calcium from the sarcoplasmic reticulum in muscle cells. So due to increase the calcium concentration in the muscle cell, it can causes skeletal muscle contraction. So this is the mechanism of acetylcholine on a smooth muscle as well as the skeletal muscles. So aim of the this practical is to study the bioassay of acetylcholine using Rat Ileum or colon by 4-point bioassay method. Instruments are used here: thermostatically controlled organ bath, chymograph, aerator, tuberculine syringe, thermometer, stopwatch, dissection instruments, beaker, and pipettes, etc. Physical salt solution is tyrrhed solution, temperature 37 degrees centigrade, animal rat ileum, drug standard acetylcholine solution 10 microgram per ml, as well as test acetylcholine solutions, which concentration should be determined by this practical. Isolate the rat ileum as described in below video as per experiment number 6. So dear students, so one hand put on the rat head, and another hold the tail and pull the tail in down. It can causes the dislocations of spinal cord. So due to dislocations of spinal cord, so rat can be anesthetized. So you can see in the video. So after this, prepare the animal for to cut the abdominal cavity by putting on a bag on operation board. So then with the help of the surgical scissors and forceps to cut the skin above the abdominal cavity, and also to cut the muscles, that is abdominal muscle. So that is cutting the thoracic cavity to smooth helpful for to so smoothly remove the GIT tract outside the animal body or from the abdominal cavity. So this is the stomach. So this one is the ileocecal junction, the junction between the small intestine and large intestine. So just the above the ileocecal junction, that is the locations of ileum, and just below the junction of stomach, that is the duodenum, and between duodenum and ileum, that is the locations of the jejunum. From ileocecal junction, you can cut. So that is the start of the, that is the end of the ileum. From the above, that is all part is a ileum. Just above the ileum, that is the jejunum, and above the jejunum, that is the duodenum. So the 1/3 of the small intestine, that is the ileum. So that's why we are cutting the lower part or above the ileocecal junctions. So then set up the student organ bath as described in experiment number 5. The temperature of the organ bath was maintained about 37 degrees centigrade with the help of heater and thermostat. record a dose response curve or DRC of standard acetylcholine solution using at least 4 doses. First, record baseline for 30 seconds. After, add 0.1 ml of acetylcholine solution and record responses due to additions of zero point 0.1 ml of acetylcholine solution for 30 seconds. Stop the drum, change the thyroid solution at least 2 to 3 times. After washing period, record the baseline for 30 seconds. Add 0.2 ml of standard acetylcholine solution and record responses due to additions of 0.2 ml acetylcholine solution for 30 seconds. After 30 seconds, stop the drum, change the ringer solution, then record baseline for 30 seconds, then add 0.4 ml of acetylcholine solution and record the responses due to additions of 0.4 ml acetylcholine solutions for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solution at least 2 to 3 times. After that, take baseline for 30 seconds and add zero point 0.8 ml of acetylcholine solutions and record the responses due to additions of 0.8 ml of acetylcholine solutions for 30 seconds. So after 30 seconds, once again stop the drum and change the thyroid solution. So this is known as the DRCF standard acetylcholine solution. Then record DRC of acetylcholine solutions using at least 4 doses. First, record baseline for 30 seconds. After that, add 0.1 ml of acetylcholine solution and record the responses due to additions of 0.1 ml of test acetylcholine solution for 30 seconds. So after 30 seconds, stop the drum, change the thyroid solutions, and after washing period, record the baseline without any drug for 30 seconds. After that, add 0.2 ml of acetylcholine test solution and record responses due to additions of 0.2 ml of test solutions for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solution. So after washing period, once again record the baseline for 30 seconds and add 0.4 ml of test acetylcholine solution and record responses due to additions of 0.4 ml of acetylcholine solutions for 30 seconds. So after 30 seconds, stop the drum, change the thyroid solutions, then record the baseline for 30 seconds without any drug. After that, add 0.8 ml of test acetylcholine solution and record responses due to additions of 0.8 ml of acetylcholine solutions for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solutions. So this is the DRCF test acetylcholine solutions. So after recording DRC of standard acetylcholine solutions as well as test acetylcholine solution, select 2 concentrations of standard drug as well as test drug, electing submaximal responses like S1, S2 and T1, T2, bearing the dose ratio 1:2 perfectly. And second condition, the test responses lie between 2 standard responses. That is, S1 responses should be smaller than T1, T1 responses should be smaller than S2 and S2 response should be smaller than T2. Then T1 and T2. So here from the graph it clearly indicates that the height of the responses of S1 is smaller than T1 and T1 is smaller than S2, then S2 smaller than T2. And we are consider S1 that is 0.2 ml of responses and S2 0.4. That is 0.4 divided by 0.2 is 2. That is a 1:2. Similarly, the same is applicable to the test, that is the test T2 is 0.8 and T1 is 0.4, that is 0.8 divided by 0.4, it is a 2. After selecting two doses from standard and two doses from test, then add S1, S2, T1, T2 them to organ bath in random fashion or Latin square design. The following Latin square may be used to ensure good randomizations and to account for the fluctuating sensitivity of the tissues. Like first, record response due to S1, then S2, T1, T2, that is set 1, set 2. Start with S2, T1, T2, S1, then third set T1, T2, S1, S2, fourth set, that is a T1, S2, S1, S2, T1. So record baseline for 30 seconds without any drug. After that, add 0.2 ml, that is S1, according to Latin square. Then record responses due to additions of 0.2 standard acetylcholine solution for 30 seconds. So after 30 seconds, stop the drum and change the tiered solution. Then after washing period, record the baseline for 30 seconds. After that, add 0.4 ml of standard solution and record response due to additions of 0.4 ml standard solutions or S2 for 30 seconds. So after that, wash the tissues and record the baseline for 30 seconds. Then add T1, that is 0.4 ml of test solution. Then record responses due to additions of 0.4 ml of test solution for 30 seconds. And here use separate syringe for standard drug as well as separate syringe for the test solutions. Then change ringer solution, then record baseline for 30 seconds, then add 0.8 ml of test solution and record responses due to additions of 0.8 ml of test solutions for 30 seconds. So after 30 seconds, stop the drum, change the tiered solution, then record baseline for 30 seconds. So after that, to record the responses due to second set of row according to Latin square, that is the start with the S2, add 0.4 ml of S2 or standard solution and record responses due to additions of 0.4 ml of standard solution for 30 seconds. After 30 seconds, stop the drum and change the ringer solution. Then after washing period, record the baseline for 30 seconds, then add 0.4 ml of test solution and record responses due to additions of 0.4 ml of test solutions for 30 seconds. After 30 seconds, stop the drum and change the tiered solution. Then after washing period, record the baseline for 30 seconds, then add 0.8 ml of test solution and record response due to additions of 0.8 ml of test solutions for 30 seconds. So after 30 seconds, stop the drum and change the tiered solution. Then after washing period, take baseline without any drug for 30 seconds, then add 0.2 ml of standard solution and record responses for 30 seconds. After 30 seconds, stop the drum, change the tiered solution. Then after washing period, record the baseline for 30 seconds. So here the drum was completed. Then you can use the next drum or fresh drum. Then in the drum 2, start with set 3 responses according to the Latin square. So add T1, that is 0.4 ml of test solution and record responses due to additions of 0.4 ml of test solution for 30 seconds. After 30 seconds, stop the drum, change the tiered solutions. Then after washing period, record the baseline for 30 seconds. Then add 0.8 ml of test solution and record responses due to additions of 0.8 ml of test solutions for 30 seconds. So after 30 seconds, stop the drum and change the tiered solution. So after washing period, record the baseline without any drug for 30 seconds. Then after 30 seconds, add 2.2 ml of standard solution and record responses due to additions of S1, that is 0.2 ml of standard solution for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solution. After washing period, record the baseline for 30 seconds. Then add 0.4 ml of standard solution and record responses due to additions of 0.4 ml of standard solutions for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solution. After washing period, record the baseline. Then go for the set 4 responses according to Latin square. So set 4, it can start with the high dose of test, that is add 0.8 ml of test solution and record response due to additions of 0.8 ml of test solutions for 30 seconds. After 30 seconds, wash the tissues. Then record baseline. Then add 0.2 ml of test solution and record responses due to additions of 0.2 ml of standard solution for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solution. So after washing, record baseline for 30 seconds, then add 0.4 ml of standard solution and record responses due to additions of 0.4 ml of standard solutions for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solutions at least 2 to 3 times. So after washing period, record the baseline for 30 seconds without any drug, then add 0.4 ml of test solution, then record response due to additions of 0.4 ml of test solutions for 30 seconds. So after 30 seconds, stop the drum and change the thyroid solutions at least 2 to 3 times. Then after that, tissue can be normalized. The writing lever came to the original positions. After that, once again, record the baseline. After that, so recording the different doses or randomizations or responses due to additions of S1, S2, T1, T2, then measure the height of the responses in mm for both drum 1 and drum 2. For drum 1, that is S1 responses is 41 mm, then S2 responses is 85 mm, then T1 responses is 65 mm, then T2 responses is 108. This is the responses of the set 1 according to the Latin square. So after that, go for set 2, then S2 responses is 92 mm, then T1 responses is 64 mm, then T2 responses is 103, then S1 responses is 41. So this is the responses in mm of set 2 according to the Latin square. So after that, go for the measurement of response mm for drum 2, then set 3 according to Latin square. First, the responses of T1 is 58 mm, then responses of T2 is 107 mm, then responses of S1 is 48 mm, then responses of S2 is 85 mm. Then go for set 3, that is the T2, response is 106 mm, then S1 responses is 41 mm, then S2 responses we got 75 mm, then go for T1 responses, it was 59 mm. So this is the completions of the measurement responses set 3 and set 4 according to Latin square or by responses on the drum 2. So after that, all the data are tabulated by using the following tabulations or observation table and calculate the mean of S1, S2, T1, T2. For example, S1, that is first time response 41 plus second response 41 plus third time response 48 and fourth time response is 41, then divided by 4 we got the 42.7. Like that, S2 mean was 84.25 and T1 mean was 61.50 and T2 mean was 106. And to calculate the unknown concentrations by 4-point bioassay method by using the following formula, that is N1 by T anti-log bracket open T2 minus S2 plus T1 minus S1 divided by T2 minus T1 plus S2 minus S1 into log N2 by N1 bracket close into a standard concentrations. So here N1 and N2 are the doses of low dose of standard and low dose of and high dose of standard, that is S1 and S2, and T is the doses of low doses of test responses in ml. Then S1 capital, it is average responses of low dose of standard. S2 average responses of low dose of that is high dose of standard, and T1 average responses of low dose of test, and T2 average responses of high dose of test, and here CS is the standard concentrations. So regarding calculations, so all the data they are put in the formula, and we can got the 6.929 microgram per ml. So these are the steps involved in the calculations of unknown concentration of test solutions by 4-point bioassay method. Result: the concentrations of given sample of acetylcholine by 4-point bioassay method is 6.929 microgram per ml. So here all the data are taken for demo purpose. These data do not have any relation to real research data. Thank you.